Okay, so quick Cliff Notes version of how to use the Keyence 3D scanner for, in this case, I'm using this part from the GD&T class, and we're going to use this to take some measurements off of and compare this physical 3D print to the theoretical 3D model. So the only thing I'm going to change for this scan, because it's a relatively simple one, is just change from the normal to fine measurement mode. What that changes between those two is going to be the kind of resolution of the lasers it projects across this. Manual gives you a bunch of different settings and options which you can mess around with in the future, but for this project, for this class, auto is going to be more than good enough for such a simple shape. So I'm just going to hit measure, and then you'll watch as it projects all of these lines across the shape. It'll do more passes and it'll do tighter tolerances with the fine resolution scan as opposed to the normal one. I'm actually going to hit cancel here because I already have the 3D scan. I don't want to wait 3 or 4 minutes for that to finish. So let me go over to here. I'm going to go ahead and delete all of these. Once you have your 3D scan brought in, first thing we're going to do is switch from our data acquisition. This is the view that you're going to get once the scan is done. And you'll notice that the bottom is hollow. For the sake of this project, that's okay. But what you could do is you could then do another data acquisition, or probably the easier way to do it would be hitting data composition, and then flipping the part on to sit on this end and doing another 3D scan and then joining them together. For this, we don't need to. So I'm going to go ahead and switch to our 3D analysis. This is what's going to let us take measurements of the part. And then I'm going to do the GD&T measurements here. And then I'm going to switch to the basics here. So for this, where it's just made up of flat planes and cylinders, that's all we're going to use. So I'm going to go ahead and define each of the cylinders by double clicking on them with the mouse. And then I'm going to hit OK next. Double click on the next one, OK next. Do that for all these, like so. Now, as I went through each of these, it gave me diameters. So for this project, you'll be writing those down and comparing that to what you've measured. I'm going to go ahead and hit OK. I didn't write any of those numbers down because I don't need to, but you would probably go a little slower through that and double click on one and then write down the diameter measurement and then double click on the next one, go from there. I'm going to define these planes now. These ones you won't need to pull any of this information off of because we are just defining planes and we're not taking any measurements of the surface yet. We're going to then use those planes if we switch to our 3D view, which you should only see 3D and GD&T. So I have those other two pulled up because this model's already been measured. We're going to do the plane-to-plane measurements, and for that I'm going to go ahead and turn this back on. I'm going to turn off visibility of this first view. You won't need to do that. So these are all of the cylinders that I've defined, and these are the planes that I've defined as well. I'm going to double click on 2 of the planes here, and that's going to give me a distance between the two, so 550 thou in this case. So I would write that down, and then I'm going to do the next segment here, which is 448 thou here at the top. And then I'm going to do this last segment here. And I'm double clicking on all these, by the way. This program just really likes double clicks. And then 345 thou, and I'm going to click OK. Now, because this doesn't have a bottom face, because it can't see that on the single scan that we did, we're not going to measure this last distance. You could composite those 2 scans like I was talking about earlier, and then you would have a flat surface here to measure from, but I'm not going to worry about that. So we've got all of our measurements and distances here. Now what we can do is compare the actual 3D printed object against the model. These dimensions and diameters that it's given us are averaged out, and kind of it's placing cylinders and planes of best fit. But if you zoom in on it, you'll notice that you can see kind of the bump pattern of the surface, and you can see the imperfections of the surface. So if we want to actually see, how different the change in tolerance is with each of these kind of lumps that you see here, or this is what's called the Z seam on a standard 3D printer. Standard meaning a FDM printer, which is most home use printers are going to print using extruded filament, and as part of its process it's going to have a seam everywhere. It stops one layer and then moves up and starts the next one. So if we want to see, let's say, how much this Z seam either protrudes or how far shy it is, we can import our CAD reference up here. Click import, and then this is our 3D scan. We're going to go ahead and browse for our 3D model. You're going to want a step file for this. Most other file formats are tessellated, as in made up of triangles, whereas a step file is going to be actual cylinders, like truly round cylinders, as opposed to made up of a bunch of segments of flat faces. So for best results, you want a step file. And I've just exported this from Fusion 360. I'm going to hit OK. It's going to process. And then I'm going to hit settings to align using the shape. And we have kind of our preview on the right hand side, and then this is our 3D scan, and this is our 3D model. This is going to work pretty similarly to what we were just doing for defining planes and cylinders. I'm going to double click on that, and I'm going to double click on the corresponding one there, and it's going to start aligning these. And I'm going to use the cylinder now, and I'm going to double click on any one of these cylinders, as long as we're clicking on the corresponding cylinders. I wouldn't want to click on this cylinder on this view and then the small one up here. I want it to be the same one. This is going to give us a rough alignment here. This looks mostly good. One thing you will notice is this flat surface, for some reason, is like different between these. So what you could do is you could maybe delete that first plane alignment and try another one and see if it seems to be any closer. At the end of the day, it seems like they're all off by a little bit, so it doesn't really matter. And then we're going to click OK, and it's aligned both of our scan and our 3D model. I'm going to click OK here. It's going to process that, and then once that's done processing, we'll be able to use this 3D compare up at the top here. And this is our alignment that we've just created, so I'm going to click OK. And this gives me a visual understanding of where all of my tolerances are off, and this gives me an idea of how far off they are. So we're within 1/8 of an inch. That's pretty good for 3D print. I mean, for an FDM print like this, that's fine. Like I was talking about, the Z seams, you'll notice these little stripes of inaccuracy that are pretty consistent. That's to be expected with a 3D print like this. Anywhere that is green is dead on, anywhere that is blue has more material than is needed, and anywhere that is red has less material than is needed. That's everything for taking measurements off of the 3D scan and comparing it to a reference CAD file.